So the book has many important ideas, and of course, the underlying theme of the book and its companion book is how do we have the best possible life, which includes doing our duty to others, including future generations. And an important part of doing our duty to others is sustainability. And I say that there are two kinds of sustainability. One is real, and the other, it's sort of like, it seems to be actual sustainability, but it is not. It is only fleeting. So let me start by first noting that 6.73 million is a lot greater than 1. Okay, so we can all agree on that. 6.73, that is 6,730,000, is a lot greater than 1. Okay. So at its core, sustainability is providing sufficient physical and cultural resources to future generations, which they would require for a good life. We can, not controversial, that's how we think of sustainability. And normally we think that we should not deplete Earth's resources at an unsustainable rate. So the concern is that we are depleting Earth's resources at an unsustainable rate, and commonly it is suggested that the course of action should be to reduce the rate of depletion and the rate at which we are changing our ecosystem by changing our production and consumption behaviors. As an economic policy that involves taxing goods with negative externalities, and the main target is carbon. The amount of carbon dioxide which is being released in the atmosphere. Okay. However, Earth has a certain carrying capacity, right? And there is no reason for us to just limit ourselves, put ourselves in this box, and think only of Earth. There's nothing sacrosanct about the Earth. Future generations can have wonderful lives, better than the ones they would have on Earth. They can have wonderful lives in space. So sustainability may be real sustainability or fleeting sustainability. And if we provide only a tiny fraction of the resources that it is possible to provide future generations, which will last them only a few hundred years, whatever we do on Earth, will last a few hundred years or even a few thousand years, then we have what I call fleeting sustainability, which is an oxymoron because sustainable means something which continues and fleeting is something which is soon gone. Just the initial phase of colonization of our solar system, according to the calculations of Space Habitations, which I provide in my book, just the initial phase will provide home to 54,000 trillion humans. So if you say that sustainability means providing resources to future generations and not depleting the resources that would be available to them, then obviously you want to provide them also the resources of space. And this is only the first phase, okay? It does not include the mass from Earth, Venus, and 99% of the Moon. And of course, it does not include the mass of the gas giants either. This is just based on the mass of asteroids and planets like Mars and the moons. So the initial sustainable solar carrying capacity multiplier is 6.73 million, the number that we encountered at the very beginning of this video. So the point being that you can try to provide a sustainable Earth to 8 billion people or 7.9 billion people, which is where we are right now. Or you can go and just colonize the initial part of our solar system, the initial phase, and that will provide home to 54,000 trillion humans, which is 6.73 million times larger than what you could have on Earth. So if you're really thinking of the future, and you think of future generations, and you want to provide them physical resources, which is what sustainability is about. You don't want to take, you don't want to like ruin the ecosystem that we have on Earth. That's how usually people think of sustainability. You don't want to ruin the ecosystem so that future generations cannot have a good life. So if your concern really is what resources you leave for future generations, then you can either remain on Earth, like this tiny speck, or you can colonize the solar system. You can start the process. You don't have to do it all. It's a process which will take a few hundred years, or maybe even 1,000 years. But it'll take it should not take all that much time. Won't be done in our lifetimes, but we have to do our part of this grand project. And when you do that, for every one person on Earth, you can instead have 6.73 million people in our solar system having luxurious lives. So I call this number the initial solar sustainable carrying capacity multiplier. We take Earth's carrying capacity as like somewhere around 8 billion, and then we have the carrying capacity of our solar system in its initial phase to be about 54,000 trillion humans, and when it is fully colonized, our solar system, this number jumps to about 438,000 trillion humans. It increases by a factor of about 8. So if we are really concerned about sustainability and we want to preserve the resources of Earth for future generations, why should we not also work to make available resources of space for future generations? It's kind of illogical to say we should care about the Earth's environment, and the Earth has a carrying capacity of 7.9 billion. I'm just assuming that whatever the current population of Earth is Earth's carrying capacity. I doubt actually it is Earth's carrying capacity, because we have introduced some very, I believe, unsustainable changes to our ecosystem, like using chemical fertilizers to dramatically increase crop yields. I don't know how long that's going to be possible to continue doing that. And so I think really the sustainable carrying capacity of Earth is less than the current population. But even assuming it is a current population of 8 billion, where does that leave us? Well, it leaves us with 8 billion people on Earth, or 54,000 trillion people in our solar system. So, this idea that we should only care about Earth and not about the resources of space when we are thinking about sustainability is just an illogical position. It's based on the failure to understand the possibilities that advancements in science offer. So we are in an ecological crisis, and it's having a population, supporting a population of 7.9 billion on Earth. And if you kind of actually think of our galaxy, according to the calculations in the book, we can provide luxurious lives to 219,000 trillion humans. Of course, some will say that, yeah, but what's the big deal about having more humans? And then the point is that, I believe I have a good life. I'm happy I was born. And I believe that people in the future who will be born will similarly appreciate the life that they have. So it is an achievement for us to be able to provide the resources for more people to have happy lives in the future. And the standard of morality in the book, which I call comprehensive utilitarianism, has that idea that we should be providing resources for more people to have good lives. And when we are able to provide resources for one more person in the future to have a good life, that is a success. So coming back to Earth, like suppose, we just say that, okay, let's just think about the Earth, and we kind of follow the best environmental policies. For example, the zero carbon policies, like where does that leave us? Where does it get us? Not very far, because even though the carbon emissions issue is likely going to be solved in a few decades, because really solar energy is competitive economically, and it is going to replace fossil fuels. So it will be solved in a few, I don't think it'll take more than a few decades to solve the issue of increasing carbon dioxide in the atmosphere, but other sustainability risks will remain until we get to space. So if we are to support a population of 8 billion, the changes in our ecosystem will make it unsustainable within a few hundred or at most a few thousand years. So besides carbon, there are other many worrying signs for our ecosystem. There's been a 75% decline in over 27 years of total flying insect biomass in protected areas. And this is from some academic papers which you can actually, the references are there in the book. You just like, there are many things which are worrying signs for ecosystem. Okay. Also, for example, there is like environmental pollution of heavy metals. Now, I like to go for hikes, and I live in the southwest part of United States, and when I go for my hike, my friend and I, we just kind of, we are walking through the wilderness, and you just find like things have been discarded. There's some piece of wire, there are some cans, and these are all heavy metals which did not really belong in that part of the ecosystem. And that pollution, once the metal, if it's iron, it rusts and it mixes with the topsoil. How are you going to rid the topsoil of that metal? I think it's very difficult, and I don't think that pollution is going to, this is like a pollution which is maybe 100 years old. And what about like the next 1,000 years or the next 10,000 years? So we are at an unsustainable rate of pollution and consumption of resources, which not only affects us, but we are a very expansionist species. We are depriving other animals on Earth also of their habitats. If you have the book, you can read the appendix, how long can Earth provide resources for humanity, about the various different ways in which our ecosystem is changing. Also, even if you don't think about pollution, there are other risks of living just on Earth. So we are currently in an interglacial period. And that this period began about 11,700 years ago. So a human, warming due to human activities may delay the next ice age. But if you look at the graph of temperature, you will see that these ice ages are periodic. It is going to happen. It may not happen for a while, but when it does happen, it will lead to a severe reduction in agricultural output, which will be followed by mass starvations. The only way we can not face like great famines is by colonizing space and freeing ourselves from all this bad things which can happen in the future. So sustainability that is just confined to Earth is no more than a fleeting sustainability. As Stephen Hawking said, I think the human race has no future if it doesn't go to space. So to all those who worry about sustainability and work to have sustainability, I would say that by all means spend some of your energy and effort to address short-term threats like notably the rising levels of carbon dioxide in the atmosphere. However, do not lose sight of the fact that there is simply no comparison between the carrying capacities of Earth and space. If your concern is future generations, and you do not consider space, then you're failing the test of reason. So you should really distribute your effort between very short-term threats or very, very short-term threats, which I say are threats which the next 100 or a few thousand years. Because given that we can just on Earth or in our solar system, we have about a couple billion years left for the sun. So a few thousand years is a very, very short period of time. So yes, if you are spending your time and energy on addressing short-term threats to the ecosystem, like the rising levels of carbon dioxide in the atmosphere, that is good, that is very good. However, do not lose sight of the fact that the big price is space. It's the resources of space. We are this tiny speck in the universe. And we want to give future generations, we want to expand and give them the resources of our solar system. And then we want to give them the resources of our galaxy. And then we want to give them the resources of other galaxies. Of course, we can't do that all in one lifetime, but we can do our part. If every generation does its part, then we will succeed, humanity will succeed. There will be many more happy babies born, there will be many more adults who would have achieved great things. There will be many more people who will travel, will write books, will find love, will have friends. So starting from this little speck, we spend a bit of effort to get to our solar system, build habitations in our solar system, then build habitations in our galaxy and then other galaxies. And this does not need a whole lot of investment. So if you are concerned about the short-term threats, by all means spend your time and effort on it, but devote a fraction of that time and effort to human space colonization. Okay. You'll be surprised at how a little properly planned and properly directed effort, what great benefits it will give to future generations. It's a misconception that if we are concerned about human space colonization, that we have to ignore what we have on Earth. Even if we give like 10% to human space colonization of what we are giving to current short-term problems, that'll be more than enough. We would have done our duty to future generations. So only a plan for sustainability that provides resources for future generations for millions of years should be considered real sustainability. Anything which is just a few thousand years is a very, very short term, given the time which the universe has left. We should really be thinking in terms of billions or even trillions of years of human existence. I am a believer in humanity. I believe that we will see reason, and we will provide more humans with the means for a wonderful life. So, of course, I just have a table in the book, and it's the table of sustainable carrying capacities and multipliers. So, if we just mine 1% of the moon and we build space habitations, then the sustainable carrying capacity of those space habitations will be 2,600 billion compared to 8 billion on Earth. Similarly, if we mine the resources in our solar system, which does not include the mass from Earth, Venus, and 99.9% of the moon, but it does include Mars, we can provide sustainable ecosystems in space habitations for 54,000 trillion people. And that is 6.73 million more than what we can provide on Earth. And if you take this and you say, okay, what is the number of future humans, not sustainable capacity, but simply future humans who will have the opportunity for a good life, then that is 1,000 trillion. 1,000 trillion greater than the number who are present on Earth at this point in time. Moving on to the entire solar system, and if we get the resources of the entire solar system, which includes the mass of Earth, Venus, and Moon, then the sustainable capacity of the ecosystems in the space habitations jumps to 438,000 trillion, or so that's about 8 times larger than the initial phase, and the multiplier will also be 8 times larger. Then we kind of move on to like the galaxy. Now, of course, galaxy means that we are going to colonize other solar systems, and that is only the next phase. Okay, so if you want to stop here and you're impressed by the number 438,000 trillion and you want to get to work making that happen, that's fine. You don't have to think about the galactic sustainable carrying capacity, but in case you're curious, that works out to something like 219,000 trillion based on the number of solar systems which are there in our galaxy, and the multiplier is 28 billion, and the foundational multiplier for our galaxy is 84 nonillion. I did not know that word till I started writing this book, because I needed all these new numbers, or at least this new number when I started writing this book, because these numbers are so large, you don't really come across them in your daily lives.